The final synchronization primitive that I want to talk about is the semaphore. Now remember, when we looked at countdown event, for example, you would basically just decrease the counter all the time. Now with the semaphore, what you can do is you can both increase it and decrease it. So there's basically functions for doing both. Let me show you how it works. And we'll start by making a semaphore, and I'll make a semaphore slim here, like so. So essentially the semaphore, and I guess I should be doing it in the main function, for example. So the semaphore takes two arguments. Actually, you can only start with one argument, or you can provide two. Now the first argument is the initial count. Remember, these synchronization primitives, they all use a counter of some kind. So here what you do is you specify the number of requests that can be granted concurrently. So essentially we can specify two requests concurrently, and then there is also a second argument, and the second argument specifies the maximum number of requests that can be granted concurrently. So in this case you can specify it as 10. Now the idea is that you basically have for example separate threads which both request something from the semaphore. They request a certain number of threads to be executed simultaneously, and other threads are kind of, maybe they're in a producer-consumer relationship, they actually decrease the number of these slots. So let's make, for example, 20 different tasks. So I'll have a counter going from 0 to 20, and here I will simply task.factory.start new once again. So we'll have them doing something. So I'll write line that we are entering a particular task. So entering task and then task.currentID, and then I'll also do the same for exiting, or let's actually call this processing. So let's suppose that we can process the tasks depending on the semaphore. So here the idea is as follows. You take the semaphore and you say semaphore.wait. And what this essentially means is that the release count, that internal variable inside the semaphore, gets decreased. So let me note this down here. So release count does a minus minus here. Now somewhere else, maybe in some sort of coordination task, you can have this release count also being increased. So let me show you how that works. So while semaphore dot current count, while the current count is, I'm going to say less than 2, what I'm going to do is I'm going to collect input. Let me read key here. And after the key is read, I'm going to increase the release count by 2. So essentially every time I press a key, I'm going to allow 2 more threads to execute. So the way this is done is as follows. You say semaphore dot release with a value of 2. Obviously avoiding any spelling mistakes. I'll also do a write line here to specify the semaphore count. It's going to stay at 2 throughout our execution because we don't have much contention or anything, but still it's very interesting to look at. So semaphore current count is that counter variable. So essentially we spawn 20 threads, but all of them can only execute work when the release count is 2, and we're going to release count by values of 2, thereby allowing 2 threads to execute. So as I execute this, you can see that we have entered many of the tasks, and we have even managed to process 2 of the tasks because that was what the starting value is. So now we're actually entering all the 20 tasks that we've created. So here we are. We have entered all the tasks, but I need to press a key, and that's when I allow 2 tasks to execute. So I press it again, I press it again, again, and I keep pressing it, and we are done. We are essentially executed all the remaining tasks, and we have completed the program. So the semaphore is perhaps one of the more confusing synchronization primitives because it's a counter that can go both ways. But essentially it still works in pretty much the same fashion. It causes a block whenever you wait on the semaphore, And to actually unblock this, you release a certain number of execution slots, if you will, by changing the release count. So at this location, this is essentially release count plus equals 2, because that's the number that I've provided here. So you allow a certain number of threads to execute. So these are some of the synchronization primitives that are available.